Introduction.
Why are you marking circles on the calendar? Actually, I have class tests on these days. I have to note these dates in my notebook. Don't you have any test on the complement of these days? Complement? What does that mean? Oh, you don't know complement? No? Come, I will explain you.
Operations on sets. Intersection. The intersection of two sets A and B is the set containing those elements which are elements of A and elements of B. We use this symbol for intersection. Example, if A is equal to 3, 4, 6, 8 and B is equal to 1, 2, 3, 5, 6, then A intersection B is equal to 3, 6. Look at this diagram now. This dark portion indicates A intersection B. Disjoint sets. Two sets are said to be disjoint if they have no element in common. Or we can say that two sets A1 and A2 are disjoint if their intersection, that is, where phi is the empty set. For example, 1, 2, 3 and 4, 5, 6 are disjoint sets. The sets of alive and dead people are disjoint. The disjoint sets can be represented by means of Venn diagram as shown. Properties of operations of intersection. Intersection is a commutative operation. A intersection B is equal to B intersection A. It is an associative operation. A intersection B intersection C is equal to B intersection A intersection C. The distributive law is true. A intersection B union C is equal to A intersection B union A intersection C. Law of phi and U. Phi intersection A is equal to phi U intersection A is equal to A. Idempotent law. A intersection A is equal to A. Operations on sets. Difference. Given set A and set B, the set difference of set B from set A is the set of all elements in A but not in B. We can write A minus B. Look at this Venn diagram. This shows us the difference of the two sets S1 and S2. Take a close look at this figure. Elements in A only are B, D, E, G. Therefore, A minus B is equal to B, D, E, G. Notice that although elements A, F, C are in A, we did not include them in A minus B because we must not take anything in set B. Sometimes, instead of looking at the Venn diagrams, it may be easier to write down the elements of both sets. Then, we show in bold the elements that are in A but not in B. A is equal to B, D, E, G, A, F, C. B is equal to K, H, U, A, F, C. Complement of a set. Given a set A, the complement of A is the set of all elements in the universal set U, but not in A. We write the complement as. In other words, the complement of set A, denoted by A dash, is the set of all elements in the universal set that are not in A. The shaded area outside A represents A dash. The number of elements of A and the number of elements of A dash make up the total number of elements in U. That means n times of A plus n times of complement of A is equal to n times of U. Examples of complement. Take a close look at the figure. D and F are in U, but they are not in A. Therefore, complement of A is equal to D, F. Let's find the complement without looking at Venn diagram. We show in bold the elements that are in U but not in A. A is equal to A, B, C. U is equal to A, B, C, D, F. So, complement of A is D and F. De Morgan's law. In set theory, De Morgan's law relate the three basic set operations to each other: the union, the intersection, and the complement. De Morgan's laws are named after the Indian-born British mathematician and logician Augustus De Morgan. If A and B are subsets of a set X, De Morgan's law state that complement of A union B is equal to complement of A intersection complement of B. Complement of A intersection B is equal to complement of A union complement of B. Here, this denotes the union, this denotes the intersection, and this denotes the set complement of A in X, that is, practical problems on union and intersection of two sets. Let A and B be finite sets. If A intersection B, which is equal to phi, then n times of A union B equals to n times of A plus n times of B. N times of A union B equals to n times of A plus n times of B minus n times of A intersection B. If A, B and C are finite sets, then facts. The sets A minus B, A intersection B and B minus A are mutually disjoint sets. That is, the intersection of any of these two sets is the null set. Descriptive set theory is the study of subsets of the real line and, more generally, subsets of Polish spaces. It begins with the study of point classes in the Borel hierarchy and extends to the study of more complex hierarchies such as the projective hierarchy and the wage hierarchy. Let us summarize what we have learned. The intersection of two sets A and B is the set of all elements which are common. The difference of two sets A and B in this order is the set of elements which belong to A but not to B. The complement of a subset A of universal set U is the set of all elements of U which are not the elements of A. For any two sets A and B, complement of A union B is equal to complement of A intersection complement of B, and complement of A intersection B is equal to complement of A union complement of B. If A and B are finite sets such that A intersection B, which equals to phi, then n times of A union B is equal to n times of A plus n times of B. If A intersection B not equals to phi, then n times of A union B is equal to n times of A plus n times of B minus n times of A intersection B.